The positive distance.
Absolute value is a distance from, at this point in your mathematical lives, the absolute value is the distance from 0 on a number line, right? In physics, absolute value is the, does anybody know? Any of y'all physics? Right now? Physics, the absolute value is the magnitude or force of a vector, okay? So it's still a distance, but you have to calculate it a little bit differently. You have to use the distance formula. All right, next semester in trig, when we're doing trigonometry, the absolute value is going to be, we're going to be doing the absolute value of complex numbers, and that's going to be something different. All right, so, but all these things are kind of related. In a linear space, a two-dimensional space, which is what we're working with, the absolute value is the distance from 0 on a number line, all right? Actually, that's just a one-dimensional space, right? A number line just has one dimension. So it's the distance from 0 on a number line. And we're going to use that concept in these coming lessons to deal with how to interpret absolute value inequalities. I don't want you to just memorize a way to do this. I want you to understand what we're working with. Absolute value is distance. Okay, it's a quantity that we're going to be using in a lot of different ways as we move forward. Okay, this says the absolute value of x plus 3 is equal to 5. Now this is a pretty simple problem, right? The problem has absolute value bars in it. Because absolute value is a distance, you always need to split the problem into two different problems. Why would we need to split this into two problems?
Because the number inside the bars could be positive or negative.
The number that's inside the absolute value bars could be 5 in this case, or it could be negative 5, because there's two numbers that have a distance from 0 that is equal to 5. So this number, this quantity in here, has a distance from 0 that is 5. That means x plus 3 could either be 5, or x plus 3 could be negative 5. If x plus 3 is either of those values, then our equation here is going to hold true. All right? So that's what we're going to always do. You're going to keep it the same for one of them, and then you're going to split it into two different equations. X plus 3 can either be 5, or x plus 3 can be negative 5. Now, I don't want you to memorize a way to do this. I want you to understand why we're doing this. All right? The quantity that's inside this absolute value bar, if our distance from 0 is equal to 5, then the quantity that's in there can either be negative 5 or it can be positive 5, because those are the two values that have an absolute value of 5. Okay, when we start talking about inequalities and our distance is greater than 5 or our distance is less than 5, then it gets a whole lot more complicated if you don't understand the concept of what we're talking about. Absolute value is a distance. Then you'd solve each of those inequalities. Very, very simple. It's not inequalities, equations. And we get two solutions here, x equals 2 or x equals negative 8. How would you check to confirm that this actually works? Kirsten? Replace the x in the original problem with 2, and you would get 2 plus 3, which is 5. And the absolute value of 5 is 5. And if we replace x with negative 8, we get negative 8 plus 3, which is negative 5. And negative 5 is also 5 units from 0, so the absolute value of negative 5 is 5. So both of these solutions do check out. Now, this is not a scenario where you have to check it because we might have an erroneous answer. Absolute value problems are going to give you a correct solution as long as you are understanding the concept that absolute value is a distance and setting your problems up correctly. All right, y'all remember this? Many of you completely remember this. This is easy. You would have known what to do without this. Jamie's so enthusiastic today. I had a professor from the Netherlands, and he talked really funny. But he would say, you guys aren't being very enthusiastic today. Enthusiastic. Finally, one of us just stopped and said, Dr. Buskus, what does enthusiastic mean? We don't know what that is. And that's his way. He said enthusiastic. enthusiastic. Right through there. So Jamie, you're not being very enthusiastic today. All right, next one. So following the previous example, we're talking about absolute value, we're talking about a distance. All right, the absolute value is a grouping symbol. It's not like other grouping symbols. What are we not allowed to do with absolute values that we're allowed to do with parentheses? Do what? Take them away? Well, we can take them away, but we got to do something different. To remove parentheses in an equation, what do? We use the distributive property. We're not allowed to use the distributive property with the absolute value grouping symbol. We're not allowed to use the distributive property with the radical grouping symbol. Right? We're only allowed to use that distributive property with parentheses and brackets. So this grouping symbol takes on a different meaning. Right? The absolute value, that quantity that's inside here has a distance from 0 that is equal to what? You guys are dead. 15, thank you. It has a distance from 0 that is equal to 15. So the quantity that's inside can either be 15 or it can be negative 15. That's correct. So we're going to split that up into two different equations, and we're going to solve those two equations, and we get x equals 3. And then when we solve the other equation, we're going to get x equals negative 7. Incidentally, let me make a little comment about the last test. I think I made some notes in tests on people. How you work your problems very neatly, Murphy, right? It's so easy to lose a negative sign on a piece of paper, and some of you transferred it down and then it just kind of disappeared because it got blended in with something else. How neatly you work things is important. So keep your work orderly so I can see it and so you can go back and see it and catch your mistakes and not lose little details like negative signs, right? That's just a little side note. So x equals 3 or x equals negative 7, how would we check that? You substitute 3 in there. What's 3 times 3? 9 plus 6?
15.
An absolute value of 15 is 15. So that works, right? And if we put negative 7 in there, we get 3 times negative 7, which is negative 21 plus 6 is negative 15. And that is the other value we were looking for because the absolute value of negative 15 is also 15. Okay? All right. Now here we go. Changing the game just a smidge here. Zach, what do you think we need to do first here?
Split it into two problems?
No. We're going to eventually split it into two problems, but only once we get what? We have to get the absolute value bar by itself, right? What splits? I was expecting a correct answer, Zach. I didn't mean to.
It's okay.
All right? We have to get the absolute value part by itself before we can apply the definition of absolute value. At this point, I'm not ready to split this because I don't have the absolute value equals something. Right? So just like when we solve radical equations a little bit later, we want to get the radical expression by itself so we can get rid of the radical. We square both sides to get rid of radicals. Right? In this, we have to get the absolute value bar by itself so we can get rid of this grouping symbol. The only way we can get rid of that grouping symbol is to apply the definition of absolute value and split it up into two problems. So the first step is to always get the absolute value by itself. So we'll add 4 to both sides. And then we'll have an expression that we can split. Now the absolute value of 2x minus 1 equals 13. I can use the definition of the absolute value and split this into two problems. The quantity inside the absolute value has to be what? What does it have to be? It has to be 13 or negative 13. That's right. right? Then we can solve those two equations and go from there, okay? X equals 7 or x equals -6. And we could go back into our original equation and check that, right? 2 times 7 minus 1. 2 times 7 is 14. 14 minus 1 is 13. And 13 minus 4 is 9, right? Then we can check the other one. -6 goes in here. 2 times -6 is -12. -12 minus 1 is -13. The absolute value -13 is 13. 13 minus 4 is 9. It's a quick check, so you should always do that. Now, let's go back to this splitting part here, because I want to point out a mistake that students make. Here's what I see a lot of times when it comes time to do this test. What did this student do? Why would they do that? Anybody? Can anybody think of why someone might do that? Because this is a very common mistake in these problems.
Inside, I guess. Like instead of changing the 13,
Well, what they're doing is
put negative on both sides.
well, they're erroneously applying the definition of absolute value. If someone thinks that the absolute value makes things positive, then they're likely or inclined to taking the absolute value of the -1 and making it 2x plus 1 when they take it out. All right? But the absolute value doesn't make things positive, right? What does the absolute value do? It's taking the distance of the quantity. Okay? And that's an understanding that I really want you to get. We don't take the absolute value of pieces of things, just like if we have a radical, we wouldn't take the absolute value of this. So the common misconception is that if we had the absolute value of x minus 2, that you could take the absolute value of the pieces of this thing. These things are not equal. The absolute value applies to the whole quantity, and so this entire quantity is what we're talking about the distance of. So we can't change the pieces of it, just like we can't take the absolute value of 16 plus 9 and make that 4 plus 3. I said absolute value, I meant square root, right? You can't take the square roots of pieces of things. You can't take the square roots, or you can't take the absolute value of pieces. This is kind of like the whole term thing, right? This absolute value applies to the entire quantity, not to the individual pieces. So what you see in absolute value, you just treat it as something that can't be changed. The only thing we can do to change that is to split it up into two separate equations. You guys are zombie-fied today. All right. Maybe I shouldn't have told you we're not going to have homework. Would that have worked? Then no, it wouldn't. Maybe we were doing something that was a little more challenging. But the concept here, guys, and I know you haven't been challenged with this idea because I see the misunderstandings a lot, and you shouldn't have been challenged up to this point. You've just been kind of shown how to do these things. Here's what you do with absolute values. You split them into two different things and change the sign of the other side. And it's okay to know that, but understanding the concept of what an absolute value is going to be very helpful in physics. It's going to be very helpful in trig when we're finding the norm of vectors, when we're finding the magnitude of complex numbers. These concepts are going to be very important that you understand what absolute value is.
So
All right?
Just treat them like they're parentheses.
It's exactly like a parentheses, only different. Only more so, right? It groups things together, but in a parentheses, yeah, I mean, we have some leeway. We can do things with parentheses that we can't do with absolute values. Here's how you should think of what's inside the absolute value. You should think of it as blob. It's a quantity that you can't do anything with. It's a blob. Look, Miss Cloud's online. Y'all remember Miss Cloud? We should Skype her one day. She could say hello to you guys. All right, so you think of it as a blob. We can't do anything with it. You cannot manipulate that thing. You can't distribute to it. Of course, if it's just a number, then we could do something with it, because we could take the absolute value of numbers. But it's just a blob. It's just a quantity in there. So if we have the absolute value of 6, then that blob has to be 6, or that blob has to be -6, because those are the two values that have a distance from 0 of 6. You can't change the blob. You can't change what's inside the absolute value. The pieces of it, you can't do anything with it. Now, what would you do with this problem? Somebody. Mary, what do you think you'd do with this problem?
X minus 4 is equal to -3.
Okay. Or?
X minus 4 is equal to 3.
Okay, so what we're doing there is just following the bouncing ball. Don't leave. This would give you 2 incorrect answers. Now listen, does anybody know why? Yes, Megan. Why can't it be a negative number? Because the absolute value is a distance, and can distance be -3? Distance cannot be -3, and we'll pick up here
So would
tomorrow.
it be easier just to keep